Refer to textbook page 228. Speed. Speed is defined as the rate of change of distance. Apabila ada rate atau kadar di sini, ia akan melibatkan masa ataupun time. Okay, so to determine the speed of an object, we will divide the distance with the time. In the meanwhile, the average speed is defined as the rate of change of total distance traveled. The difference between the speed and the average speed, we added a total distance and a total time here. So if you want to calculate the speed only, no need to involve the total distance or total time. Tetapi jika ingin kira laju purata, perlulah libatkan total distance and the total time. The SI unit for both speed and average speed is meter per second. M small letter, S small letter. Negative 1 here because the second is placed over below the fraction. S negatif 1 di sini adalah kerana saat, iaitu unit untuk masa, terletak di bawah pecahan ini. Okay, so unit for distance is a meter and unit for time is a second. That's why the SI unit for speed and average speed is a meter per second. Now let's understand this diagram. A 100-meter runner will experience change in the distance the moment he starts running from the starting line. This is the 100-meter runner. Here is the starting point. How can you determine this is the starting point? Because the distance stated here is 0 meter. Berarti dia belum melakukan sebarang pergerakan pada kedudukan ini. The moment he start running, he will experience the change in a distance. Apabila dia mula bergerak, dia akan mengalami perubahan jarak. The change in distance increase as the runner become increasing further away from the starting line. Semakin dia jauh daripada starting point, semakin banyak perubahan jarak berlaku. At point A is the nearest point with the starting point. Therefore, perubahan jarak only 10 meter, which is the shortest one. Then, the more he further away from the starting point, the more bigger the change in distance. Point B, 50 meter. Point C, 100 meter is a point where the finishing line here. The speed of the runner can be determined by the distance and the time taken. So when we want to calculate the speed of the runner, we can use this formula: distance over time taken. Distance you divide with the time taken. So here are some examples of calculation for the speed of the runner. Speed of a runner at position A. So when we refer to this diagram here, this runner can reach 10 meter in just 2 seconds. Pelari ini boleh lari jarak 10 meter dalam tempoh 2 saat. Therefore, to calculate the speed of this runner at position A is to divide the distance and the time taken to reach at this distance. So when we substitute the value 10 meter and 2 seconds in this formula, we will get the speed at the position A is 5 meter per second, as well as the speed of the runner at position B. Okay, so by referring to this diagram, the runner at position B travel about 50 meter in just 6 seconds. dalam tempoh 6 saat, dia boleh capai pada jarak 50 meter. Therefore, his speed at the position B is 50 meter. You divide by 6 seconds. Then you will get 8.33 meter per second. Here are example of calculation for the average speed of the runner. Is because the average speed need to involve the total distance and the total time. Therefore, we need to get the total travel distance. So in this diagram, the total distance is 100 meter. Okay, so jarak keseluruhan ialah 100 meter. And he finished 100 meter distance by only 10 seconds. Therefore, we substitute 100 meter and 10 seconds in the formula here. Therefore, we will get the average speed is equals to 10 meter per second. Purata laju pelari ini ialah 10 meter per saat. Refer to textbook page 229. Velocity. Velocity is defined as the rate of change of displacement. Speed ialah laju, manakala velocity ialah hal laju. Remember in previous class, teacher explained the difference between distance and displacement. Displacement must indicate the specific direction. Sesaran mesti menunjukkan arah yang spesifik. Is because velocity is defined as the rate of change of displacement, ada kena mengena dengan sesaran. Therefore, velocity also must show the direction between the 2 points. Unit for displacement is meter and unit for time is second. Therefore, the SI unit for velocity is the same as the speed, which is meter per second. Let's understand this diagram. The car above starts to move from initial point O to the final point C, which has a displacement of 12 meter to the east. 12 meter to the east. Go here. So the car experiences a change in displacement. Here is the initial point. How do you know this is initial point or kedudukan awal? Because stated here is 0 meter. The moment of this car move from initial point O, it will experience the change in displacement. Apabila kereta ini mula bergerak, dia akan mengalami perubahan sesaran. Sama seperti laju tadi, semakin kereta ini bergerak jauh daripada initial point, dia akan mengalami banyak perubahan sesaran. The more this car move, the more the change in displacement. The velocity of this car can be determined by the displacement and the time taken by the car to reach at point C. Here are the example of the calculation for velocity of the car. Velocity of the car from point O to A. From this diagram, the point O to A, the displacement is equals to 4 meter to the east and the time taken is 2 seconds. Therefore, the velocity from the initial point to A is 4 meter divided by 2 seconds. So we substitute the value, we will get the velocity of the car from point O to A is 2 meter per second to the east. B. Velocity of the car from point A to B. To get the displacement from point A to point B, we need to minus the displacement at point B here and at the point A here in order to get the displacement here. Therefore, displacement at point A to the B is 8 meter. You minus with 4 meter, you will get 4 meter. So displacement from point A to point B is 4 meter. The time taken here is 2 seconds. Therefore, the velocity is 4 divided by 2. You will get 2 meter per second to the east. C. Velocity of the car from point O to C. So here from point O to C. First, we need to determine the displacement. Okay. So in order to get displacement, we need to minus the displacement at point C with the displacement at point O. Is because the displacement at point O is 0 meter. Therefore, if we minus the 12 meter with 0 meter, we will get still 12 meter. Okay, so the time taken here will be the overall time taken. Okay, the 2 seconds you plus with this 2 seconds and another 2 seconds, you will get all is 6 seconds. Therefore, the velocity from point O to C is equals to 2 meter per second to the east. Sometimes the velocity can give the value of negative. Kadang-kadang nilai halaju boleh jadi negatif. The positive and the negative sign in the value of velocity show the direction of motion of the car. Nilai positif atau negatif pada halaju adalah untuk menunjukkan arah pergerakan. Okay, so by referring the figure 11.5, when the car travels to the east, its velocity is written with a positive sign. The velocity of the car in the opposite direction could be written with a negative sign. Sekiranya kereta yang ini tadi ini berpatah balik, okay, dia berpatah balik. So, yaitu arah pergerakan dia bertentangan dengan arah pergerakan pada awalnya, maka hal laju itu akan ditulis dalam nilai negatif.